It's best to unsubscribe from the events when the subscriber is no longer needed. Let's take a close look at a situation where forgetting to unsubscribe to an event can be a little bit problematic. In the Windows application that we previously used as an example, I am going to introduce the order processor. When the user of the application presses the button to process the order, this will start the order processing, as well as showing a window that will in its turn listen for when the order processor completed. Basically, the main window and a receipt window will share a reference to the order processor. The receipt window will subscribe to the order created event. When that event occurs, it can act on that information. Each time you press Process Order in the main window, it will create a new instance of the receipt window and pass the order processor. Let's look at how to express this in code. First, add the order processor as a property on the main window and create an instance in the constructor. Again, this isn't a course on WPF or how to best build UI applications, but this will simply and fairly easily illustrate a problem that you can run into when working with events. The receipt window will accept the order processor, which we can store in a private field. We want this window to subscribe to the order created event, so that it knows when to display the order receipt. Let's subscribe to this event using a Lambda. To keep it simple, we can display a message box that we received this event. It looks fairly simple, doesn't it? Now we can head back to the button click event handler that is supposed to create an instance of this window. We are going to create the instance, pass the order processor, and then show the window. After that, we can call process on the order processor. So far, it doesn't look very odd or wrong, does it? What happens if we run the application and click the button? It seems like it's working as expected. Pressing the button process order does in fact open another window, and it does show a message that the order is created. If you close the receipt window and press the button again, what happens? Ouch! That didn't work completely as expected. Did you notice that we received two message boxes? If you repeat this process again, close the receipt window and press the button, there will be three message boxes. This is definitely an issue. Do you know what happened here? The event handler for the order created event was invoked 3 times. Why is that? We completely closed the receipt window. We no longer have a reference to that window, but somehow the delegates are still executed. This is exactly why it's important to unsubscribe from your events. The garbage collector is unable to clean up the receipt window because there's a delegate associated with it. The anonymous function created using the Lambda is still associated with the invocation list on the event handler delegate. How would we unsubscribe in our situation? As I've previously mentioned, there's no clean way to do this. This is one of the issues with using an anonymous function as an event handler. This won't always be an issue. It really boils down to the fact that the order processor is a shared instance. It's not too uncommon of an issue, so how do we best fix this? In this case, it's better to not use the Lambda, but instead create an event handler as a separate method. It's an easy change. All we do is introduce a method called processor_order_created and move the code from the Lambda into this method. We still need to unsubscribe this method from the event. You want to do this when the instance is no longer relevant. In this case of this window, we could do this when the window is closing. There's a method that we can override called onClosing, which is in fact also in its turn calling an event. But that's beside the point. In this method, unsubscribe the method from the event before calling the base onClosing. If you rerun the application with the same test as before, this will now yield a much better result. Each instance of the receipt window will be cleaned up as it's closed, and there's no longer an event handler leak. The message box should show only once each time you click Process Order. Hopefully, this is convincing enough to show you why it's very wise to unsubscribe from the events. I want to highlight that this is not only a problem in UI applications. This can happen in any type of application and could cause unexpected problems. The sample application is a simple way to show a way to reproduce this issue. Don't be surprised if you run into this in the real world. I definitely learned about this the hard way myself. In my case, I had an application. Accidentally, an event handler was not unsubscribed when one of the views were closed, much like in our sample. The view that handled the purchase of an item wasn't properly disposed, and it didn't unsubscribe from its events. When a signal was sent that a purchase was completed, this resulted in an extra receipt being printed for each purchase that had occurred. Imagine my surprise when I tested this. Luckily for me, the issue was promptly discovered, and with a good understanding of events, it was very easy to solve. Let's look at this from a different angle. Take this class as an example. The whole idea behind this class is to handle some sort of logging. When you create an instance of this class, you inject the order processor. At a first glance, this may not seem odd. The class then registers itself as a subscriber on the publisher, which is the order processor. This means that the order processor's event that you subscribe to has a reference to this class and its referenced method. Unless the class implements a pattern to unsubscribe its methods from the publisher, this is a bad idea. If you create an instance of that class and inject the order processor, then immediately after that, you set the reference to null. The event handler would still be invoked. This is because the publisher still has a reference to the instance. That instance cannot be cleaned up by the garbage collector until that reference is removed. The only way to remove that reference is to unsubscribe from that event. Exactly how you proceed to do that in this scenario can vary. This is where it's important to consider the overall architecture of the application. You want to do your best to avoid this type of design. In this particular instance of the logger, an alternative approach could have been to remove the order processor from the constructor, and instead register an event handler at the application level, which will then call the method log on this logger. You could then make sure that you unsubscribe the event handler at an appropriate time, for example, when a view closes. Another approach is to implement iDisposable, but we'll get to that in the last module of this course. The most important takeaway from this is that you should always unsubscribe your event handlers. Plan your application architecture so that it's easy to do so.